Yes. Okay, thank you. All right, that's very quick to change because no one has to go to the toilet, get some coffee, no? No? Okay, perfect. All right, thanks for having me. It's awesome to be at the Google user group, as a Microsoft person. So I'll be, in the next 40 minutes or so, I'll be giving you some overview of how we as in the Microsoft space look at developing for Android. And for that we are going to be using the tool called Xamarin. Has anyone already heard about Xamarin? A couple of people? Yeah, cool. So I'm going to show you a quick overview of what you can do with it, and also as a maybe a native Android developer, also get some benefit out of using instead of your regular Android tools, switch over to using Xamarin, and then also get some benefit out of it. So my name is Gill. I'm working here for a company called Ordina here in Belgium, quite a large consultancy firm, where I do the mobile architectures, so the larger mobile projects. I also do a lot of things for Microsoft. I'm an MVP and a regional director for them. And if you have any questions, feel free to contact me. My details are on the slide here. I also do a lot of online training. For example, about Xamarin, I have a lot of courses online that you can take a look at if you want to get some more info on building applications with Xamarin. I do that for a company called Pluralsight, which is active in basically all technologies. They started out as a Microsoft training company, but they also do native Android development. They also do, like what you can see here, Xamarin, but they also cover Java courses and stuff as well. So this is the link where you can find all my courses if you're interested in browsing some deeper in the Xamarin world. So what I'm going to show you is let's say a bird's-eye perspective of what Xamarin offers you as a developer, as an Android developer. I'm going to show you first what the platform is all about. I'm going to show you one of the biggest benefits that you get in moving to Xamarin, even when you're doing native Android development. I'm also, and that is going to be sharing code, of course. I'm going to also show you the Xamarin Forms way of working, which is, well, a bit of a twist on top of the Xamarin Android. And basically what I'm going to be showing you is the actual Xamarin mobile solution, because building for Xamarin is not just the code, but is building in a Microsoft world. On top of what Microsoft is offering is an entire mobile solution. So let's get started by taking a look at Xamarin first. And let me first explain you a little bit what Xamarin is all about. So, if you would have asked me, like, I think 3, 4, 5 years ago, if I would be talking at the Google user group about Microsoft's way of building Android applications, I would have asked you, is hell frozen over? But apparently not, because I'm here talking to you about how we can build Android and iOS applications. And the way that we do that is Xamarin. And what Xamarin is basically all about, it's basically a large plugin to the tool that we use, which is Visual Studio, that allows us to build native iOS and native Android applications. And I'm emphasizing the native aspect here because it's not a web-based technology that we're going to be using, it's actually native applications that are going to come out of it. It allows us to reach all major mobile platforms, so that includes iOS, Android, and of course also Windows Phone and Windows desktop applications such as Windows 10 universal application. And the applications that we build, like I said, are native applications. And because of that, we get all the benefits out of it as well. So that means that we can build applications with native user interface elements, and not mimicked or fake UI elements. No, it's actually the native UI elements that we will be using. And since we're actually compiling into native applications, we're also getting the native performance out of it. Now, one of the big benefits that I'm going to be spending a lot of time on is the shared code aspect. The shared code, because we can, with Xamarin, build iOS, Android, and Windows applications, is really in terms of the amount of code that needs to be written and the amount of time spent to create an application is really a big benefit. You're actually going to be able to share code across the different platforms. And of course, you are going to be building everything on top of Microsoft technologies, that is C# and .NET. It is, like I said, a toolset on top of Visual Studio, so the IDE that Microsoft has been building for many years now, and it enables iOS and it enables Visual Studio to output native iOS and Android applications. It used to be built by a separate company, so Xamarin used to be a standalone company, but it was acquired by Microsoft in March, late March of this year. So it's now actually part of Microsoft. And that also takes away one of the blockers for many companies to switch to Xamarin, because now it's part of Microsoft. It's basically the only way, the way forward to build mobile applications on top of Android and iOS with Microsoft technologies. It was a bit of a blocker because it was a separate company, and customers were sometimes afraid because it's not a big company that was behind it. But now it's part of Microsoft, so that's all good. And in terms of the approach that we are getting with Xamarin, we're talking about the no-compromise approach. And I'm going to refer to that quite a few times. The no-compromise approach means that the applications that we are going to be generating with Xamarin are native applications. So you're not going to have to say, well, we can't really build that design, or we can't really access that native feature. No, it's not going to be the case. Everything that we are building is a native application, and so you get access to the full feature set of the operating system. Like I said, Xamarin, so that's basically in a nutshell what Xamarin is. But the Microsoft approach to building mobile applications is not just focusing on the development part. And that I want to show you throughout this presentation in a bit more detail. So of course we are going to be able to build mobile applications, so we're going to be able to write code that targets iOS, Android, that also can even target a desktop Mac OS application. But next to the development part, Microsoft also tries to give us as developers the full suite to building mobile solutions. And so that includes also automated and integrated testing, that also includes automated builds of mobile applications, and also that also includes monitoring and distribution of the applications. I'm going to come back to these parts later in the talk. Let's focus first on the development part. So how are we going to, or how should we be actually be building mobile applications? What's the difference where Xamarin is really shining compared to what you have with a native approach? I've been doing mobile for quite a few years now, and I see quite a lot of customers, and this is basically the approach that many companies that you all use their mobile apps, that they have been using, or that have been applying, let's say. Some time ago, some CTO, CEO, or whatever said, well, we need a mobile application. And so they jump on the mobile bandwagon, they get in a team, and typically they started out with the iOS application. Very often the iOS application is their reference application. And so they got in a team that knows Xcode, that knows Objective-C, and they built the iOS application. All happy, happy, joy, joy, but then the Android users start complaining because they also want an application. So what that company will then do is they get a team of Java developers that do Android development, and they build next to that the Android application. And sometimes there's one Windows guy that says, I also want a Windows application. Sometimes happens. And then they get in a C# team, and they also build the Windows Phone application. Right? And so what you end up with is three code bases of three native code bases that actually can't share a thing, because apart from the analysis, basically, they all have to write the entire code stack 3 times. Well, that's a bit of a problem. Initially, it's quite expensive to build all that, but think of the maintenance cost that comes with it. It's crazy. The maintenance cost is several times the amount that, it will cost you several times the same amount that you had to initially build the application. So this is the siloed approach, and apart from the fact that these actually generate native mobile applications, it has a bit of a downside. It's expensive in the long run, definitely very expensive. Some companies have thought that they found the holy grail in moving to a platform that offers us mobile applications that run everywhere. And something that runs everywhere is typically JavaScript, HTML. And so you get something like an Ionic framework or Cordova framework. And those things, well, they actually allow you to build an application which is not native, of course, but it runs on the 3 platforms. And I should actually say it runs on the 3 platforms. Because it's not a native application. The performance is different. The nativeness of the UI is mimicked. It's not real. It's HTML, JavaScript, CSS running. So you don't always get the same performance as you should. Of course, the cost to build this is quite a lot lower than with the siloed approach. But if you look at the user experience and the performance, you'll get a less than optimal feeling. So that's the write once and run everywhere approach. The benefit is, of course, it's a lot cheaper. But if we can take the best of these 2 worlds, well, then we actually arrive with what Xamarin is offering. So what Xamarin is offering us is one shared code base on which we build the 3 native applications. And of course, everything is going to be built with C# because Microsoft is, of course, putting all its money in C#. And what you build in here is your models, your data access, your SQLite access code, your service access, your business layer, and so on and so on. And on top of that shared C# code base, you actually build the 3 native applications also in C#. So you will actually still be building native applications in iOS with a storyboard, in Android with XML code, and in Windows also with XAML and C#. So C# is the language that you're going to be using end to end, and you're still building 3 native applications. And they are really native applications, but instead of using Java or instead of using Swift or Objective-C, you're going to be using C# from top to bottom. That's what Xamarin is offering us. And this, of course, has a big benefit in the fact that you have a lot of code that you can reuse, and you're building native mobile applications, giving you the high performance that you need in a good native application. And so on top of the .NET framework, for a Windows application, you get some APIs which are extra exposed on top of what .NET is offering us. You get the same thing in iOS. You get the same thing in iOS, also the typical .NET APIs, and on top of it, typical iOS things like UIKit, MapKit, Core Graphics, Core Motion, and in Android, you get the same thing, the same API, the same framework, with some Android specifics that you can target from your native application, like text-to-speech, printing, NFC access, and so on. So everything that is offered in the native framework is going to be accessible directly from Xamarin. Now, like I said, the applications are native applications. It is not a mimicked structure. It's really a native application. I'm not going to go too much into technical details, but this is more or less how things are done. So if you build an iOS application is going to be, when you build it with the Xcode, is going to be compiled into ARM statements, native platform-specific statements. And so what Visual Studio with Xamarin will do, it will compile, it will convert your C# code directly into ARM statements. So that when you push your application to the Apple App Store, nobody can actually still see that that application was originally written with C# and Xamarin. There's physically no difference in what comes out of Visual Studio compared to with an Xcode compiled application. For Android, it's actually a bit simpler. It uses its own virtual machine, more or less. That's a bit, it's not really 100% correct what I'm saying, but that's what it's doing, more or less. And it's actually building your APK file with, inside of it, an intermediate language application package inside, or intermediate language code base inside of it. And when the application runs the first time, your intermediate language is going to be cross-compiled, or compiled, not cross-compiled, using something called just-in-time compilation, and it will actually run a native application on top of your Android phone. So that's basically how it's done. There's a lot of technical stuff going on behind the scenes, but the net effect is that you can just do everything with your C# code base on both iOS and Android. It's also always up to date. Microsoft and previously Xamarin themselves gave a guarantee that when a new feature comes out for both iOS and Android, that they have an API update within 24 hours. And that is still the case. And it's not only limiting us to a native, to an Android phone and an iPhone. It is actually covering everything that you can do with Xamarin, with Android. So that means Android Wear, Fire devices from Amazon. If you would still have a Google Glass lying around, you could actually build an application with Xamarin that targets Google Glass. So all the other types of devices where Android is running on, you can actually build Xamarin applications for those as well. And like I said already quite a few times, everything that you can do in Xcode for iOS or in Java for Android, you can actually do that with Xamarin as well. Now the development experience is actually pretty simple. You download Visual Studio, and if you download the free version of Visual Studio, that's Visual Studio Community Edition, it already comes with Xamarin. So simply click on the installer or run the installer, and probably not very readable, but in the optional features to install, you can actually click Xamarin and it will install Xamarin for free with Visual Studio. So all the development that you want to get started with Xamarin, you can actually do it for free. There's no cost. You can actually download the free version of Visual Studio, and it comes with Xamarin included in there as well. Once you have things installed, Visual Studio has been updated actually quite some time already ago. That allows you to, for Android and both for iOS, to have a drag and drop designer that is very similar to the one in Android Studio. You can drag your controls. You can also, of course, edit the XML yourself if you're not a fan of the drag and drop designer like me. So you can actually open the XML files in here, and you can actually build your interfaces like you would do it in a native Android Studio. The designer also features the abilities to preview the screen in multiple resolutions, in landscape, portrait mode, with different features enabled, disabled. If you want to see how the interface runs on a Samsung Gear, for example, we can also do that here. The interesting thing is also this, of course, uses the same XML files as a native Android application, so the one that you built with Android Studio. So you can go to Android Studio if you do not like the designer here. You can open that XML file in Android Studio or in Eclipse or whatever you want to use. You can edit it there and then save it back to Visual Studio, and it will work on the same XML files. There's physically no difference in the files that are being generated in terms of the UI. That also explains why the application that you're building is using a native UI. If you want to do everything on Windows, of course you can continue using the Google emulator if you love to do that, but Microsoft also offers a Hyper-V emulator, which is a lot faster than the built-in Google emulators. They have been updated quite some time, this year I think it was, that they were updated. But actually the Hyper-V emulators, and Hyper-V is the virtualization technology that comes with Windows. There is a Hyper-V emulator available for Windows as well, which enables you to run your applications on that emulator very, very fast actually. It actually also works if you still want to do native Android development in Android Studio. You can also use this emulator, by the way. So even if you don't like the Xamarin part, you can still use this emulator. You don't need any extra installations of VirtualBox or Genymotion. You can use the Hyper-V emulator out of the box. I'm actually still a fan of Genymotion because I purchased a license some time ago. I still use Genymotion quite a lot, but this one actually is also very fast. And if you're on the Mac, of course, Visual Studio does not exist yet on the Mac. I say yet, but there is a small version which is Visual Studio Code, but that does not enable you to do Xamarin development. But if you want to do Xamarin development on a Mac, it's also possible. This is a tool, or an IDE from Xamarin, which is now also, of course, part of Microsoft. And it's called Xamarin Studio, and it allows you to do exactly the same thing. You can also edit your XML files. You also can write your C# code, and you can compile your native Xamarin Android applications, but then using your Mac. And if you're a bit afraid of everything that's going on behind the scenes, Microsoft has open sourced Xamarin earlier this year. It's available via open.xamarin.com, so there you can see the entire Xamarin SDK. You can even contribute if you want to accept a pull request as well. All right. Let me very quickly give you a view into how Xamarin works. So this is Visual Studio. It's pretty small because the resolution is pretty high here on my device and it's not taking it there, but anyway. So what you see here is Visual Studio with Xamarin enabled. Let's zoom in on the project structure for a minute. There we go. So if you look here, so this is the Xamarin application itself. And if you compare this with a native Android application, you'll see that it is pretty similar. You also have your resources folder, your layout folders, your drawable, your bitmap folders that are down here at the bottom. The major big difference is, of course, that everything, all the code is in C# files, so .cs files, as you can see here at the top. So all the code that I'm writing is going to be written in C#, top to bottom. So, for example, if I have an activity, these are my fragments. So here are my activities. If you look at the activity code, I hope you can read it. I had enlarged it a little bit. There we go. So if you take a look at what you get here, well, it's a class that inherits from activity, has an activity attribute, and this contains my code that will typically go in an activity. So the way that you build an Android application is, of course, pretty much the same. And I'm running the application here. The mouse seems to be, there it is. So this is my application that I use here. So yeah, it's going to be compiled into a native Android application. I'm not a designer, so as you can see, this is a pretty simple UI, but it's possible to, of course, enhance that quite a lot. Suppose everything that you can do with Android. So also, for example, things like the R.java file, well, in Xamarin that's going to be a resources.designer.cs file, again a C# file, but things like resource values, all those things which you know from Android development are copied into what you get in Xamarin. So there's physically not a lot of difference. Now if you want to move to C#, of course, if you're a Java developer, is that a big move? Well, it's not such a big move. Syntax-wise, they're pretty similar. Most of these things you already get in Java. The async await is a very interesting pattern. I'm not going to go too deep into those things, but how do you then actually move? Can you simply take your application and say, well, now I want to start building it in Xamarin? Well, if you have, for example, some components that you say, well, I've spent a lot of time building those, I want to take them with me when I move to Xamarin, it's possible. If you have a UI component or a calculation library, what have you, you can simply take that natively compiled Java library or Android Java library and throw that in your Xamarin application, and it will create something called a binding library, which is an interrupt layer between your Xamarin application and your native Java library. So you can actually still talk with your native Java code. And of course, you can also start porting the code. Like I said, syntax-wise, it's not a big difference with what you get in C#. Now you can ask, why would I actually start doing that? Because I now already can do everything in my Android application. But remember what I said in the beginning. The code sharing aspect is a very important one. Because with native C, but with one code base, with one C# code base, we can target the different platforms. And that's of course a big plus. There's two options to do that. Something called a shared project, and something called a portable class library. Let me show you this. Well, a shared project is not the way that I like to work. It's something that was introduced already quite a few years ago when Microsoft introduced cross-platform development, let's say, between Windows Phone and Windows 8. It is still possible to do that with Xamarin, but I don't like doing that. I prefer the second option, and that's a portable class library. Like it says here, it is one assembly, and it can be targeted from multiple platforms. This is a dialog that you get in Visual Studio when you start building your shared code. You can say, I want to build a portable class library. And now Visual Studio will ask you, who do you want to be able to communicate, to target this portable library, this portable class library? And you can say, well, I want to have a Xamarin Android and a Xamarin iOS application, and also maybe a regular .NET application, or maybe a Windows 8 or Windows 10 application. And so what you're seeing at that point is that you have one assembly that contains all your code that you're going to be sharing across the different platforms, and you can actually access that code from different targets. So your iOS application, your Android application, your Windows application, you can even include Xbox. That's not in the screenshot because it probably wasn't installed in the SDK, but you can even share code with your Xbox application using something called portable class libraries. And of course, the amount of code that needs to be written is going down dramatically. We've been writing quite a few Xamarin applications, and on average, if we build the iOS and the Android application together, we can share about 60% of the code between the iOS, the Android, and sometimes also the Windows application. If you think about the amount of code that represents, that's quite a lot. And so you can actually gain a lot of time getting your application out there a lot faster if you target multiple platforms. If you target just one platform, it's not going to be worth it. Definitely not, because you're versed in your platform, you know your platform. But if you have to target multiple platforms, the amount of code that you can share and the amount of time that you can win is quite drastic. We averaged about between 50 and 60%. Microsoft says more, but we don't have to believe that. We have been building quite a few applications already, and we average between 50 and 60% of code that we can use. It depends on the application. If the UI is more complex, it's going to be lower, because then we can't, of course, you can't share the UI with traditional Xamarin. If the application is heavy on business logic and code and service access and business rules, then you can even share more than the 60%. It really depends a bit on the application. So how do you see that? Well, the application here that I have here in Visual Studio is zoom in a little bit. It contains two projects, and it says here, so in this case there is only an only an Android application. Typically you would have the Raise Hot Dogs, which is the name of the application. That's the Android application. You would also have an iOS application, and then everything else is in this core portable project. So typically things, and this is just a demo, but typically things like models, repositories, data access services, services that talk with the local SQL database and SQLite database, all those things you can put in this shared code. And again, it is all C#, so there's no switching of languages when you move from one project to the other. That's how you would typically share code in a Xamarin application. Let me already start this other one here, and then I can move to the last part. Now, a couple of other things that you get when you move to Xamarin is NuGet. NuGet is the package manager for Visual Studio. Maybe you've heard of it. It's like a package manager for other things. And it contains a numerous amount of C# libraries. NuGet was, of course, not created with Xamarin in mind. It was created with the .NET world in mind. But the good thing is that, let's say, 90% of the libraries which are in there, and which can be, of course, useful for Xamarin development, already have been transformed into one of those portable class libraries as well. So there's a portable class library version of libraries that work with JSON and all kinds of things. You can download them there from that NuGet package manager, and you get the ability to use your C# knowledge for accessing those functionalities from a Xamarin application as well. Microsoft is also heavily investing in plugins at this point. There's a huge list of things, of common patterns, common things that you do, which is available on xamarin.com/plugins. So things like accessing speech, accessing the camera, settings, messaging, geolocation, all those kinds of things. They've wrapped them into plugins that you can plug into your codebase. You may be asking, well, how are we going to be doing those things from a shared codebase, from a shared perspective? Well, imagine that you have an application that needs to interact with the speech API. And in your shared code, you want to say, well, pronounce this particular sentence. How are you going to be doing that? Well, it is possible, it's definitely possible, although the APIs are different. So what are you going to be doing? In your shared code, you're going to work with an abstraction. Right? And an abstraction is going to have, for example, a method called speak, and you pass it the sentence that needs to be pronounced. Your actual platform implementation lives in the application, the application specific code base. And you're going to be using an abstraction in your shared code. And in your applications, you're going to plug the platform-specific implementation into your shared code through something called a dependency injection. That should be familiar. You should be familiar with that. So what you're going to be doing in the Android application, for example, is you're going to plug from the native Xamarin Android application the API to do that text-to-speech pronunciation. You're going to plug that into the shared code base. Your shared code base does not know the implementation up until runtime. Then you plug it from here into your shared code base. So you do the same with iOS and you do the same with Windows. And that allows you to, even though that the function is not shareable because it's platform specific, it still allows you to move a lot of code to that shared code base. The last thing that I'm going to show you is, well, something that makes life even easier. What we've seen so far is called classic Xamarin. It's the traditional, it's the original way of doing Xamarin development. If I say classic, there must also be a new way of doing it. Well, the simplifying development part is going to show you something called Xamarin Forms. Now, Xamarin Forms is an abstraction on top of Xamarin. On a good day, I think someone at Xamarin said, well, if you look at the three platforms that we're targeting here, so iOS, Android, and Windows, well, all these three platforms, they have a lot of things in common. You have a button in Android, you have a button in iOS, and you have a button in Windows. Why don't we create an abstraction layer on top of these three platforms, and we allow the developer to talk with that abstraction layer instead of going on a per platform level? And that is what Xamarin Forms is all about. It's an abstraction layer that still allows you to build native iOS, Android, and Windows applications with a single shared code base. What's the difference then? Well, the difference is that with traditional classic Xamarin, we still build the Android and the iOS and the Windows specific applications. You still have to use storyboards, you still have to use XML. With Xamarin Forms, we move away from that and we extend the shared code into a shared UI block. A shared UI block in which you talk to that abstraction layer, and that will actually at runtime see that, now I'm running on Android, and you say in the abstraction layer I want to have a button. On Android it's going to be a button, an Android button. And if the application runs on iOS, then it's going to say, well, this button needs to be translated into a UI button. And when you run on Windows, that button needs to be translated into a Windows button. So you talk as a developer, you write code against that abstraction layer. And Xamarin Forms will translate your abstraction code into a real application at runtime. It is still a native application. It actually converts your button, your text field, whatever, into the native implementations of the platform. And it takes care of a lot. It actually takes care of the layout of the screen. It comes with a couple of default page templates. It also comes with a couple of layout managers that rearrange your layout automatically for you. And it comes with a lot of controls out of the box as well. It actually contains about 40 of these. And that's also, let's say, the drawback of everything. Xamarin Forms is an abstraction. So basically what they did is they said, well, let's take the three platforms and everything that we can find across these three platforms, we move it into the abstraction layer. But the things which are not common, which are not shared, are of course not in that platform. And that's why Xamarin Forms basically is limited in what you can do with it out of the box. As soon as you start digging into more specific controls which are native to Android but don't exist in iOS, well then you will have, you're not really blocked, but then you will have to create something called a custom renderer for that specific platform to be able to access that control from the platform. It's a bit more complicated. So as soon as you go outside of the lines of what Xamarin Forms offers out of the box, you can still access everything that is not included, but it takes a bit more time. And that is why Xamarin Forms is not, let's say, the default solution to do every type of application. As long as the application is pretty simple, like a conference application, a festival application, those kinds of things, well then you can definitely go for Xamarin Forms. Because the amount of code that you can share at that point is even a lot higher. We've been building a Xamarin Forms application for the last 2 months now, and we actually reach between 90 and 95% of code sharing. As long as we don't have to create custom controls too much, then the amount of time that we save is enormous. We simply have one code base end to end, and just a very thin layer of the UI needs to be changed and needs to be made platform specific. It also contains data binding, navigation frameworks, animation. I'm not going to go in these things. It actually contains quite a lot out of the box to do this type of applications. So here you see a couple of those pages that it comes out of the box with, like a master detail, a navigation, a tab page. It also contains layouts like a relative layout, a grid layout, a scroll view, and importantly, if you know iOS, you know that these things are not included in iOS, so it handles all the nitty details to convert from an abstract view that you create into something that actually looks good on iOS. And iOS development is not that easy to get everything right, depending on the different resolutions. Well, it is actually possible to do that here. They've taken away that burden from you as a developer with their layout managers that they have included. And there's controls, like I said, the button, there's an image, there's a label, all these things are in there, and they will be translated to the native functionality, the native control at runtime for you when you build a Xamarin Forms application. Remember that in that view where you had the shared UI code, there was a very thin layer that you could still tweak. There's a very thin UI layer that you can tweak. And so the code here that you see, I'm not going to go in detail on there, but it allows you to customize the platform a bit deeper. So if you, for example, say that in iOS I want to have a padding at the top, and in Android and Windows I do not want that, you can actually do that. The abstract code base, the abstract code layer, allows you to tweak your UI, let's say, per platform if needed. It's not often that you need it, but there are occasions where you do need it. The code that you actually write is written in something called XAML. XAML is a XAML application markup language. It's a Microsoft language that was invented already more than 10 years ago with the introduction of WPF, so Windows Presentation Foundation. And so they have actually reused that language to allow you to build your shared UI layer. So as you can see here, I have been using here a tabbed page that will translate in the native tabs per platform, and in there I have a stack layout, I have an entry is the text field, a stack layout will translate it to stack layout as well, of course. So this is the language that you will use to build your abstraction layer in, and that's XAML, and so all the UI code is going to be written once and then translated into 3 different native applications. Let me very quickly show you that. So when you run the application, hope I have it open here already. So this here is, well, that XAML code. If you look at it, it's not very hard to read. It's very similar to Android XML. I've actually learned this first quite a few years ago. I've been using this for other technologies as well. But this is why it was easier for me to move into Xamarin, Xamarin Android, because I already knew XAML. And XAML and Android XML are not that different. So if you look at this code, all you see, you can pretty much see what it's going to be doing. It's going to create a stack layout within the scroll view, has an image there, and then a stack layout with a label and some images and so on and so on. I don't think that's really hard to understand what's going on here. So if you run this on iOS and on Android, this code base will actually translate into a native Android and a native iOS application. So So I'm going to run it here very quickly, and you'll see that we actually end up with a native Android application. Again, this is not a web UI or something that is sitting in between. This is actually a native application. So for example, you have the draw layout here. You can click on this button here, and then you can actually have a list view of items here. You can click on these, and it will actually load the detail screen as well. So again, this is a native application on Android running here. All right, I'm almost out of time, I think, so I have 2 more things to say. Like I said in the beginning, Microsoft is not focusing just on the development part, but they're taking things a bit further. What they've introduced is, for the testing part, is something called a Xamarin Test Cloud. And it's really interesting. I've been using it quite a lot lately for testing applications, hence the name Test Cloud, I think. What is Test Cloud all about? Well, it's a physical data center in which they have over 2,000 different Android devices lying there, and you can actually write a UI test, and you can push that together with your APK into that data center, and that data center will, will take screenshots when you build or when you run your UI test on that application. So what you see here is the result of that. And so I push my UI test, and I select a couple of devices on which I want to run my my application, and then it runs through my UI test script, and it takes screenshots on the specific places in my UI test script that I wanted to visualize. This takes away the burden of having to test your application on many devices within your company. You simply push it out to the test cloud, and it will do the work for you. It will do that for you. It saves us a tremendous amount of time, because some customers want the guarantee that their application will look good on quite a number of devices. It's possible to do that with Test Cloud. The cool thing, this also works for iOS. This also works with a native application. So if you have a native Android application in Java, it still works. You can write your UI tests with Calabash, so that's Ruby, or you can write your UI tests with C# as well. So there's a UI test framework that you can use here. It is not, of course it's not free. It's actually, it depends on what you want to do with it, but the prices start, I think, at 99 euros per month to have, I think, it's quite a lot of testing hours that you get to run your tests on in the cloud. It's really nice, and it actually works quite well. Before I was coming here, I was doing a test for an application, and it actually, it works really nice. It's actually pretty fast, and well, it's an amazing technology. I've seen the data center. It's crazy. It's all racks and racks and racks with devices lying there with lots of cables, and you push your application to those devices, and it just works. It's an amazing piece of technology. And so that actually allows you to test your application on, I think currently there's over 2,000 different Android devices physically lying there, different devices. So that's a crazy amount. And I think you all know that it's not easy to test your application to make sure that it works on all these devices. Well, this is definitely a step in the good direction, because it allows you to do a lot of testing on physical devices. So this is Test Cloud. Head over to xamarin.com/testcloud, and then you can sign up for a 30-day free trial, and you can start pushing your applications into the Test Cloud. And the last thing, the build. Microsoft also includes Visual Studio Team Services. Again, this is not limited to just Xamarin development with C#. You can even do native Android development with Java in here. But the cool thing is that what Visual Studio Team Services offers is a lot of integration with continuous integration, continuous build, even automated releases to the Google Play Store. You can actually do that. I've done it a couple of times already. It's actually possible to have a continuous integration set up here that builds your Android application. It pushes that application to Test Cloud. If that gives a green light, then you can do an automated staging and even push to production on Google Play. It actually is possible to do that all out of the box with Visual Studio Team Services. Yeah, I don't have time to explain you all of that, but I know that it's possible to do that. And the last thing that they also offer for the testing, for the distribution and monitoring is something called Hockey App. Hockey App was recently acquired by Microsoft as well. And Hockey App allows you to do distribution of your mobile application, first within a team of internal testers. So you can say, well, I have my user tests, and I can automatically deploy my application to a number of testers within my company. That's what Hockey App offers. And Hockey App also offers a monitoring option. So you push your application out to a group of testers, and everything that happens within the application, so crashes, metrics, feedback even, can be integrated with Hockey App. So you can automatically get that back in the Hockey App report. Again, I don't have time for that, but there's a lot of information on the Xamarin website to dig deeper in that. Again, Hockey App is not limited to Xamarin applications. It also works with native Java Android applications. You can also integrate with the SDK. They have an SDK natively for Android, and you can also do the distribution and monitoring, so for native native Java Android applications. So as you can see, the solution that Microsoft is offering for mobile development includes a development part, includes a test cloud, includes Visual Studio Team Services, and it includes Hockey App for both the distribution and the monitoring of your application. So that was it for me. I hope I've given you an overview of what Xamarin offers for us as mobile developers. The fact that we can do a lot of code sharing between the different platforms is of course a big plus, but the fact that it's not, the tools are not limited to just a Microsoft solution makes it interesting for native Java and developers as well. All right. Okay. Thank you for listening. Yeah, if there's any questions, feel free. No questions?
So I have a question.
Yes, sure.
So for example, the Xamarin Forms, I tried to use it in the past, but I have a very, well, my first question, is it available on the desktop application, Windows desktop application?
Yes, in desktop so it works for UWP, so for the universal application it's possible. Desktop, not yet. No. Okay. So WPF doesn't work. No.
Okay, and I have a particular question, like we have an application built in Xamarin, and we had a problem that we would like to use a monogame component in there in Xamarin Forms because it allows quite some reusability, but there is like no official way or no real way how to do it. Do you know about some support or how to?
I've not tried with monogame yet, so that integration I've not tested yet. So it could be that it works, but I think those are limitations that you're running against from a Xamarin Forms perspective.
Yeah.
I don't think that will work at this point.
Okay.
Could be, but I don't think it works.
Yeah. Thank you.
Any other questions? Okay. Thank you.